this is Yitian, a graduate student at Geophysical Institute, University of Alaska, Fairbanks. In this video, I will share with you our new findings at the Makushin Volcano in Alaska. Its loose indigenous name is Yitian. The inset figures here show the location of Makushin in Alaska and the location of Alaska in the world. This Makushin volcano is one of the most active volcanoes in Alaska, having erupted at least 7 times in the last century. Eruptions from Makushin not only pose a threat to the infrastructure of nearby population centers in Alaska and Dutch Harbor, but also disrupt the busy air routes overhead, causing danger to air traffic. To monitor for eruptions and precursory activities, the Alaska Volcano Observatory, AVO, have installed several instruments on Makushin, including 5 GNSS stations, which are Global Navigation Satellite System ground stations. These stations, same as GPS in your phone or your car, but with much higher accuracy after careful processing, achieving millimeter precision. The stations are installed on ground, so if a GNSS station tells us that the position of the station is changing, it means the ground is also moving. The crust under the volcano is deforming. Between 2016 and 2018, the GNSS stations deployed near Makushin volcano recorded such ground deformation. We carefully processed the data, and the pattern is shown in this figure. The red vectors represent vertical movement, and movement is uplift. The blue vector represents horizontal movement, and the movement is away from the volcano. So vertical uplift and horizontal away from the volcano, this is a pattern of inflation. This suggests that the volcano was inflating during this period. Why would a volcano inflate? One possible reason is the ascent of magma from deep within the earth to a shallow magma reservoir. As magma accumulates, the volume of the magma reservoir increases. Surrounding rock is pressured and strained, so the volcano inflates, creating the deformation signal we can measure on the surface. We have numerical forward models that simulate the surface deformation response due to magma migration and storage of different depths and shapes. This is called the forward model. And through mathematical methods, it's possible to use the observed deformation to infer the properties of the magma movement. We call this an inverse problem. So inverse problems are to use observed surface deformation to infer magma movement and reservoir properties. We employed a math technique known as the Markov chain Monte Carlo method to solve the inverse problem of the Makushin inflation, and we found an inflating magma source located 5 kilometers or 16,400 feet deep below sea level. Between 2016 and 2018, the volume of the magma reservoir increased by 4 million cubic meters or 1 billion gallons. This source is very similar in location to those identified in previous studies, though slightly shallower. 2 years after inflation, Makushin experienced its most intense earthquake swarm. 1,000 nanoquakes occurred over 3 months. We know that earthquakes result from the accumulation and release of stress in the crust. Could the magma intrusion have altered the stress in the crust and triggered the earthquakes? We did a stress transfer analysis. This figure shows the stress change in the crust near the earthquake swarm location due to magma intrusion. The color on the map represents the magnitude of stress change. The green wet beach balls represent the field-resolved earthquakes. In short, our results show that the magma intrusion indeed led to a positive change in normal stress in panel A2, indicating a decrease in the compression between rocks, which increases the likelihood of fall to sleep. However, this stress change was not significantly large, so the earthquake swarm was likely a result of a combination effect of regional stress due to the Pacific plate subduction, the magma activity discussed before, and the cumulative effect of the first 2 larger earthquakes within the swarm. Thank you for watching this video. For more information, please check our recent research paper published in the Journal of Volcanology and Geothermal Research.